Hello, am I audible? Hello.
Yeah, you're audible.
Okay, fine. So let's start. So in this session, you'll be learning about inheritance, virtual functions, and abstract classes. So 1 second, let me share my screen. Is my screen visible?
Yeah, you can continue.
Yeah, okay. Okay, so as I said, so today we are going to be looking at inheritance, virtual functions, and abstract classes. So what is inheritance? Inheritance is the mechanism through which new classes can be created from classes that are already existing. Why do we do this? We do this to share implementations of certain methods or data members of the base class. So classes that are derived from are known as base classes, and classes um, that we create during using this derivation are known as derived classes. Okay. So now, what are the types of inheritance? There are mainly two kinds: single inheritance or multiple inheritance. As the name suggests, single inheritance is when we just have a singular base class. Multiple inheritance is when we have multiple base classes. Now, it might, okay, I will show you some examples to make you understand better. Okay. Uh, okay, so I'm presenting some code. Make it bigger. Okay. Is the font readable? I'm assuming it is. Anyways, let us continue. So now I have one class that represents an animal. And okay, I think you have learnt about classes in the previous sessions. This is just an extremely simple class. It has no data members, just has two void methods, void functions. One is sleep and one is eat. Sleep simply prints out sleeping, eat prints out eating. Now, horse, of course, is an animal, and we want to inherit, that is, take some functionality from the animal. So in this case, we are inheriting from the animal these methods. So what inheritance does is we inherit all of the functions as well as data members from the base class. Over here, horse is a derived class since we are deriving from animal, and animal is a base class since we are deriving from it. Okay? As you can notice, I do not redefine sleep over here. So what happens when I call horse.sleep? It simply calls the implementation defined in animal. However, notice that eat is being overridden in horse. In fact, horse is eating the hay. Okay, I don't actually know what a horse eats, but I think that's a fair assumption. Anyways, so when we call horse.eat, we are overriding it with our own implementation that's different from that of the base class. Now there are certain rules to overriding methods in the base class. They have to have the same name so that the compiler knows that these are in fact the same function that we are overriding. And suppose they should also have the same return type. I suppose they don't. But anyways, they have to have the same name so that the compiler knows that we are overriding this method. And I've defined a new method in horse that is name that simply prints out name. As you can see, this is the output for the program. When I call horse.eat, it sees this eat and not this since we have overridden it in the derived class. The method resolution goes from bottom to top. That is, if it goes from the child in the hierarchy up to the parent. Since horse is the lowest item in the hierarchy, it chooses its implementation over animals. Then sleep. Since horse does not define its own sleep, but animal does, it calls animal sleep. When I do horse.neigh, animal does not define a neigh method, however horse does, and that gets called. Suppose you have learnt about methods or functions, member functions in the previous session. So this should be pretty straightforward. Only difference is that we are able to inherit the methods, that is we are able to use the methods from another class without defining it twice, and we are able to override methods that are defined in that original class, as can be seen by eat over here. Coming back. So that is single inheritance and multiple inheritance. So what is the syntax for creating it? You have just seen it. We have the class keyword with the name of the derived class. I will come back to what is the meaning of virtual and access specifier. And then we have the name of the base class. So as you can see over here, I have class, the name of the derived class, which is horse, the name of the base class, namely animal. Now, coming back to access specifier, what is access specifier? We can look at it now. Access specifiers are mainly of three types. They define how they define the visibility of members of the base class as they're inherited down to the derived class. If we inherit using the public keyword, all public members of the base class are public in the derived class, and all protected members of the base class are protected in the derived class. I think I've learned about encapsulation and public, protected, and private methods in the previous session, so this should be straightforward. In public, whatever is public remains public, whatever is protected remains protected. You might notice that whatever we do not mention about private here, because in inheritance, when we define under the private keyword, those member functions and data members are not inherited. So it does not matter which access specifier we use, they will never be inherited if they're defined using private. Now coming back to this, the other access specifier we can use is protected. If we use protected, it is extremely similar to public, except that even public members of the base class are protected in the derived class. And private is also similar to protected, except that all public and protected members of the base class are private in the derived class. So that is the access specifier. And by default, access specifier is private. So if I inherit private, that is, if I don't mention anything, I will not be able to access the sleep method. As it can see, inaccessible within this context, since though sleep is a public method in animal, since we are inheriting without the public keyword, and as we have seen before, if we inherit without any access specifier, it defaults to being private. Over here, sleep is a private method of horse, hence it cannot be accessed in a public context like this. Anyways, if I add that back in, sleep is a public method and it can be used outside. If I inheriting without a keyword is same as inheriting with private, as we have already seen what it does. If I inherit as protected, once again, we won't be able to use the sleep method since it will be a protected variable, protected function that is inside horse. Okay. Now, moving on. Okay, so now we have looked at access specifier. I'll come back to this virtual keyword when we are inheriting the class later on when we discuss abstract classes. Right now, we'll discuss virtual functions because it plays into abstract classes. So what are virtual functions? Virtual function is a member function that you expect to be overridden or redefined in the derived class. So the one of the main uses of virtual functions is when you create a pointer to the base class with a reference to the derived class and you call a member function on it, you would normally expect it to call the implementation in derived, but however, that is not the case. That is not so. That's not what happens usually. If we want it to happen that way, we would have to use a virtual function. Now, to better understand this, uh, let me show you a demonstration. So over here, we have a base class that has two public methods, foo and bar. Foo is not a virtual function. It is a normal function that outputs base. Similarly, bar is also, but bar is a virtual function that also outputs base. Derived is a other class that inherits, that derives from derives from base publicly. It overrides both foo and bar with its own implementation, namely derived and outputting derived in both cases. Over here, I create a derived class and I take a pointer, and now I create a reference to the derived class and pass it to the pointer of a base class. Now, what the illust we can clearly see the difference between a virtual function and a normal function is clearly illustrated over here. When we, I think you might have seen this arrow notation to access members from a pointer. When we call the foo function of this pointer to this derived class, we actually get base and not derived, since it actually refers to the implementation found in the base class. However, if we call bar, since it is a virtual function, it actually calls the implementation in derived and not in base. So to put it more formally, call to a virtual function is resolved according to the underlying type of the object. In this case, even though the type of B is a pointer to base, the underlying type is actually derived. So the implementation that is called is the implementation of derived. Similarly, a call to a non-virtual function is resolved according to the type of the pointer or reference. Over here, the type of the pointer is base. So the call to foo is resolved with base, and therefore base is printed. And overrides of virtual functions are always virtual. So if I inherit from derived again and override bar once more, then its implementation will be called if I use that particular class. To illustrate this better, okay, I'll come back to this later. Okay, so you might ask, uh, why would I ever want to do this? That is, create a pointer to base class from a reference to the derived class. This seems absurd, but it is quite useful when we were dealing with containers that expect homologous types. For example, let us take this class animal that defines one method, eat, that simply outputs eating. Now I have two different classes that inherit from animal, namely horse and dog. Horse outputs eating hay and dog outputs eating bone. Now I suppose you might have seen this container known as a vector. It's simply a resizable array that has a dynamic size. Now I create a vector of animal and I would like to store all different kinds of animals in this. I would not want to store a horse or a dog particularly. I would want to store all the kinds of animals. So I simply create this animal vector, insert the horse and the dog into it. And now when I iterate through the animal and I call the eat method on it, I would actually want it to call the underlying implementation of horse and dog and not that of animal. However, as you see, and the eat method in animal is not a virtual function. So what do you think will be the output of this code? Would it be eating hay, eating bone, or would it simply be eating and eating? You can type your answer in the chat. No, attendance will be done later. I will repeat the question. We have a base class that is animal, and we have two derived classes, horse and dog, that inherit from animal with public. Animal has a singular method, void function, eat, which simply prints eating. Horse and dog override this function with their own implementation, namely horse printing eating hay and dog printing eating bone. I have created a vector of animals and I pushed in that holds a pointer to animal. I push in references to the horse and a dog, and now I'm iterating through the animals and calling its eat method. So what do you think would be the output? Would it be eating, eating, or would it be eating hay, eating bone? Was the question clear? Okay, I suppose there's not enough into today. I'll tell the answer myself. It prints out eating, eating, since the eat method of animal is not a virtual function. When we call the eat function, it resolves according to the type of the pointer and not according to the underlying type of horse and dog. So we get the output as eating and eating. However, we do not want this. So the easy way to prevent this is by adding virtual. Now we get, since eat is a virtual function, the eat function over here is resolved according to the underlying type. In this case, for the first animal, the underlying type is horse, so we get eating hay. And for the second animal, the underlying type is dog, so we get eating bone. I hope this use of virtual functions is clear. In fact, I have another example. I have an animal that has a name and a virtual function that is warm-blooded. Now, two kinds of animals, mammal and reptile, both of which inherit from animal through public. Mammal overrides warm-blooded and returns true. The reptile overrides warm-blooded, returns false. I don't know if this is actually correct. I'm pretty sure mammal is warm-blooded. My bio I haven't revised. Anyways, so okay, you might notice this const um, over here. What this does is essentially just says to the compiler, I am not changing the underlying data members. In fact, I can remove it if it don't serve any purpose over here. Okay. You might notice some new syntax. I equate a function to 0. Now you might ask what this means. What I do over here is when I equate this function signature to 0, this essentially means I am deleting the function. So I cannot call warm-blooded on an instance of animal. I can only call is warm-blooded on an um, instance of the classes that derive from it. What I mean to say is, if I create an animal class, I cannot call is warm-blooded on it. As you can see, since we have a virtual method that's deleted, we get a helpful hint over here that A is of abstract type and we cannot call its function. So this is what it's meant by an abstract class, in which I define certain methods. I define the signature of certain functions or functions, but I do not provide its implementation. Instead, I equate it to 0, which makes this class an abstract class. Is it clear so far? Okay, I will just explain the code over here a little bit. You want to see? Yeah, it's identical to the previous case, except I push a mammal and a reptile into this vector of animal pointers. I simply print out their name and whether they're warm-blooded or not. This std bool alpha simply converts a 0 or 1 to true or false to be human readable. Is this clear so far? Um, no response. Excellent. Uh, class. Anyways, moving forward. As we have seen, what abstract classes. So, what are abstract classes? They uh, essentially express concepts from which more concrete classes can be derived. We cannot create an instance of the abstract class. However, we can use pointers and reference to these abstract classes. As we saw in this example, we are unable to create an instance of the animal class because it is of an abstract type since it has a deleted function. However, we can use pointers to this abstract type, pointers and references to it. As you can see over here, I have a vector of animal pointers. Okay. Now, coming back to this virtual keyword, why do we need this? This comes into play when we use multiple inheritance. I'd actually skipped showing an example of multiple inheritance, which you can see over here. I simply have two classes defined. Let us say you're building a UI library and you have a clickable class which implements a click method that probably does something with the UI framework for OpenGL or something, I'm not sure. And you have a rectangle class that has a draw method that probably uh, leads to some draw calls in SDL, OpenGL, whatever, which is simply a slide where it simply prints out drawing from rectangle and over here simply prints out clicking from clickable. Now I have a new button class um, that inherits from both clickable and rectangle. So what this essentially does is it inherits both the methods draw as well as click. So I'm able to call click from button as well as draw. You might ask what will happen if I define a draw in both places, then that would actually lead to ambiguity and you can resolve it. So if I do, then simply calling draw is not feasible since when the compiler has to decide which draw function should it, which implementation of draw should it use clickables implementation or rectangles, we can resolve this by explicitly stating the base class that we want to call it from. So if I do this, then it says drawing from rectangle. If I do this, then it says drawing from clickable. However, this is not recommended. It doesn't look that nice, but this is a way to resolve ambiguities when we have similarly named functions from the base classes that we're inheriting. Let me go back to the simple example. So this is the syntax for multiple inheritance. We simply have a comma separated list of access specifier, name of the class, and virtual. Now I'll come back to what is the use of the virtual keyword when specifying the inheritance. Now let us say you're building, I don't know, the management system for your school or college. I suppose it'll be more relevant for people in college. You have a person class that has the two data members, age and name. Then you have a student class that has a method take test. You have a faculty class that has a method grade test. Students can attempt an exam and faculty can grade an exam. Then you have a special class called teaching assistant that inherits from both student as well as faculty. As you know, teaching assistants themselves are students. However, they can also grade tests. So that is why we inherit from both student as well as faculty. However, notice what happens is that when I want to set ta.age, This age is ambiguous. Now you might think, how can that be ambiguous? Age is only defined in person. However, that is not the case. Student has an independent copy of the person class, and faculty also has an independent copy of the person class. So if I directly try and attempt to access this age member of the teaching assistant class, I in fact get an error since it's ambiguous. Similar to how we resolved the ambiguity previously, we can explicitly assign we can explicitly define which base class data member are we using. So I can say I want to set the student's age to this and the faculty's age to this. However, this is absurd. Why would we want to have a person with two different ages? So to resolve this, we use the virtual keyword. What this says is I only want one copy of this base class in the hierarchy. I do not want two. In this case, I had two copies of person, one stored by student and one stored by faculty. That is why I was able to set them independently, as you can see here. I was able to set the student's age to 10 and the faculty's age to 30. And I was also able to retrieve them 10 and 30. But as you can observe, this is not what we want to model. We want to model a person that has a singular age. Therefore, we use the virtual keyword. Now, this virtual keyword can come before or after the access specifier. It does not matter. I could put it here as well. Yeah, as you can see, it still works. What this says is for any class in deriving from person, store only one copy of it. Teaching assistant essentially has two paths to person. It can go from faculty to person or from student to person. Using the virtual keyword, we both of them point to the same person class. Therefore, both of them have the um, same age data member. That is the reason we do not have an ambiguity here, since both student and faculty point to the same person instance. And as you can see, even if we try and explicitly um, get the student and the faculty's age, both are the same and both are equal to 50 that we have set over here and that we can print out. Okay. That's basically it. Do you guys have any doubts? I can clarify them now. I will show the attendance soon. If there are any doubts, you can raise your hand or type it in the chat. Okay, I guess there are no doubts. Uh, Here are the QR codes for the feedback and the attendance. Please do fill the feedback so we know how to improve our sessions. And do fill the attendance if you want to get your certificate. Okay, I can see one person raising the hand. Yeah. Can you type your doubt in the chat? Or wait, I can grant you mic access. Yeah, okay, so you can ask your doubt. I will once again show the QR code. Okay, I guess there are no doubts. I will. So that is the end of the session. Thank you for attending.